All right, CNT120, Chapter 1 Lab. We are now on Layer 4. So we left off at Layer 3. We did our IP config and we're ping. I don't actually need the command prompt open, so I'm just going to close that for now to declutter my screen. We're now going to look at Layer 4. Well, Layer 1 was our patch cable. Layer 2 was the network card, or our NIC. And along with that, the MAC address. Again, switches are reading that to move data around. Layer 3 was our TCP/IP settings, or our IP addressing. The IP addressing is something that routers are going to read to get data routed to the correct network. So we looked at the IP address and IP address settings on our machine, and we did a ping. The ping was that little data packet moving across the network and coming back. If I got a reply, I know that that layer 1, 2, 3 connection is working. When I move into Layer 4, we're now into some protocols. The big ones being TCP and UDP. Well, TCP, if we remember real quickly, it talked about TCP was the protocol that's connection-oriented, that's designed to make sure all the data gets from the sender to the receiver. So it's going to number things, it's going to label things, it's going to make sure it all gets there. So what we're going to do for Layer 4, we're actually going to look at some TCP data. We'll look at TCP data we're going to look at TCP information, if you will, on some chunks of data that we move across a network. So we're going to focus in on the TCP port numbers as we're looking at our TCP. So to do that, we're going to use a program called Wireshark. We have Wireshark installed on your desktop. Up here it looks like a little shark fin. We are going to run Wireshark, and what Wireshark does, Wireshark actually copies any data packet that's moving by on the network, makes a copy of, so that we can open it and look at it. So this program is extremely valuable and useful in doing some troubleshooting and learning about networks, as well as troubleshooting on networks. Now, Wireshark is a free program that you can download, install, and use. My caution is this: because it is a powerful program, make sure if you download it and install it, make sure it's on your machine and using it on your network at home or in our lab room. If you install this on a computer and try to run it at work, it's going to look like you're trying to compromise or hack into the network. So don't install this on any work computers. Don't run this on any work networks. But if you want to install it on your computer at home and run it on your home network, awesome. In our lab room, it's all part of learning. Okay, so this is a powerful program. It is kind of like walking down the street and looking at everybody's mail, which we don't want to do. That's a crime. So I'm going to launch Wireshark. That's my little disclaimer before we get going. I'm going to launch Wireshark, and I'm going to have this capture data. When I open a web page like hack.edu, it's going to capture all those packets so that we can open them and look at them. So what I'm going to do is I'm going to find my Ethernet 3 NIC. I'll highlight that, and I can either click the shark fin to start it, or if I double click on Ethernet 3, that'll launch it. So I will launch this. I'm going to open my browser. I'm going to close some tabs from before. I'm going to open up a brand new tab, and I'm going to go to www.hack.edu. And I'm going to load that web page. I'm going to let it load. Once it's done loading, I'm going to come over here, and I'm going to click the little red square to stop the capture. And you'll notice that I've captured, looks like around 4,300 packets so far. Okay, that's all right. We're now going to filter what we captured so we only see the HTTP data. We're going to use HTTP to look at that, and then inside the HTTP, because we loaded a web page, we're going to look for this TCP stuff. So over here in Wireshark, in this top filter bar, I'm going to plug in HTTP, and I'm going to hit the Enter key. I either hit the Enter key or click the little arrow out here to apply this filter. This says, hey, only show me the HTTP data that's in here. Okay, so only show me the HTTP data that's in here. Now, I might see some protocol in here. That's okay. That's all right. We're really looking just at trying to filter out all that stuff and just look at the HTTP. That's good enough for what we're doing today, because we're really just trying to look at what's in there. So now that I have that, we're going to highlight one of these. Maybe the first one that's here. Maybe the first one that's here. I'll highlight that. The middle window shows the contents of it. I can either use it this way and just look at what's here, or if I want to, if I double click on it, it actually opens up in a new window and I can just look at that packet in and of itself. So it's up to you. I'm going to do it this way just so it's a little clearer for you guys to see it. Now, what we are actually seeing is this HTTP packet that went by on the network. We made a copy of it and we're now having it in our hands, and we're going to open it up and look at it. Well, what it has is it has the whole thing. I have to remember my data encapsulation that we talked about. Data segments, packets, frames, bits. This gets this HTTP data off the network. As it gets it off the network, it literally starts opening it and starts printing out on the screen what it sees. So the very first header it tore off was the Ethernet header, because that's the last one added before it shipped. It tore the Ethernet header off and printed it here. It then tore off the IP header and printed it here. Then tore off the TCP header and printed it here. And then here's the HTTP data. Here's the actual HTTP data. So what I'm seeing is the actual HTTP chunk of data with all the headers that were added to it to ship it across the network. Now, they look like they're printed in reverse order, but it is really, you know, it pulled off the network, and the first thing it tore off was this, so it printed it, tore this one off, printed it, tore this one off, printed it. So this is kind of like on the receiving end. So Ethernet header, IP header, TCP header. Well, we are focused on layer 4. Ethernet would be layer 2. IP would be layer 3. TCP is layer 4. So I'm going to open this little header here. I can either double click on it or click the little arrow, and that expands it. This shows all of the header fields inside of this TCP header. And you notice there's quite a few. Yeah, there's quite a few because all of these are necessary to label these chunks so that they're shipped in order, actually shipped, and when they're received, put back in the appropriate order. And if something goes missing, they can reference it. They can actually use a field in here, sequence number, and reference it saying, hey, can you send this piece of data for me? Can you send this piece of data for me? It went missing. That's what TCP is doing. It has all these fields to keep track of everything and make sure all the data, chunks of data, get to the receiver's computer. So we want to look now. We're looking at the header fields. We saw Ethernet, IP, TCP, and I'm actually opening up the TCP header. And in here I see source port, destination port. Well, the source port in this case is coming from my browser, so it's 14,009. Well, my browser uses dynamic port numbers, so as I open a new tab, that might be 14,010. The next one might be 14,011, if you will. Okay? Those are dynamically assigned. They're assigned on the fly, if you will. So there's nothing too much to read into it other than that's coming from my browser. The destination port is 80. That's important because we're talking to a web server. Web servers listen on port 80 if it's a plain old HTTP server. We'll talk about port numbers later, but I'm at least getting you to see them now. Any TCP traffic is labeled with its protocol. What type of protocol is this? What's in here? And it uses a port number to reference that. Okay, so since we see 80, we know this is going to a web server. Or since there's web data in here, HTTP data, we're assuming it should be port 80. Okay, so right here, source and destination port. In this case, the source port was this 14009, and the destination was 80 because we're going to a web server. All right, before I go any further, I'm going to make note of that. I'm going to make note of that in my notepad file. Now, do not panic if your source port is different because it's coming from a different browser. That's fine. But the destination port on all those should be 80 because we were all trying to talk to a web server or at least look at web data. All right, so I'm going in my notepad file. I'm going to pull a note over here that this is my layer 4 data or layer 4 results, something like that. And I'm going to put in here, I'll do my source port. I'll try to copy that, see if it'll paste it for me. I'll try to paste. Oh, no, that did not work. I don't know. I'm not sure if that guy does. Let's just do field name, see if it does that. If not, I'm going to plug it in myself. Nope, we're just going to do this. We're going to do TCP source port. And I'm going to put in here 14009, and I'm going to put TCP destination port, and I'm going to port 80 because we were looking at our web traffic. Okay, and that way I know you looked at your TCP header and saw that this is TCP traffic. That is a layer 4 thing. TCP is a layer 4 thing. All right, I'll save my text file, and the next podcast we'll come back to our next layer. In this case, it'll be layer 7.